Hello everyone, welcome to another problem session. So today we have problem number 13 from 2024 JEE from India, Advanced Physics Paper 2. Okay, so what this is, you have some pressure chamber, which is pressure is this amount, close to 1 atmosphere, and there's a bubble which is soap bubble, which means gonna have two surfaces. Let me get a darker pen. Okay, so this soap bubble, and inside the pressure difference is that much, which means inside the pressure is P0 plus delta P. Outside is P0. And the reason you need a pressure difference is maintained through surface tension on the bubble. So from there you go to this situation. The pressure is reduced. It becomes 8 P0 or 27, and so the bubble will kind of expand. And maybe this radius A is A0. Let's call this radius A1, and let's call this pressure P1. And so inside now pressure will be P1 plus delta P1. Okay. In this process, from here to here, temperature is constant. Also, we're supposed to the gas inside here is amount of gas is same, but this gas is ideal gas. Think of that as ideal gas. So basically, this process is, if you look just the inside of the bubble, is a pressure changed, so the volume changed at constant temperature. And because ideal gas, that means is PV equals nRT. So this is constant in this process. So pressure and volume here must be equal to pressure and volume here inside. Okay. And another thing we have to assume is like a delta P is much less than P0. Delta P1 is much less than P1. So this is another condition. So if we have a sum of these two, like this one can be approximated to P0 in a formula. Okay. Okay. So we're supposed to find what's the delta P1. Even with this condition, we can find delta P1. Okay. All right. So first thing to notice is if I want to find delta P1, how would I go about it? Okay. You'll see that it will relate it to the surface tension of this bubble. So you have to know that if the surface tension here is sigma 1, so sigma 1 says like force. If I were to cut this into half, what's the force that's pulling them together, right? So if I go over here, the force will be pulling them apart. So So actual force, I'll have to do is pull apart like that. So the actual surface tension on the upside surface is pointed down and downside is pointed up. So just look at the upside. Let's look at just the upside. So this one surface, and the other surface is like that. And extra pressure is delta P1. So pressure is pushing in all direction on this bubble. From outside, pressure is pushing down from all direction. So the difference of this is delta P, and you can see that this direction and another pressure that way, these guys, the horizontal direction will cancel out for these two pressures. Horizontal force from these two pressures will cancel out. So as far as surface tension is concerned, there's a force down sigma 1 times this whole line. Sigma 1 is actually force per unit length. So to get the force, sigma 1 is acting along all of these like that. So it's a sigma 1 2 pi, and let's see, this radius is a1, and then the green one is the same way and different in radius, so a1, and the green one is the same. Okay, so this will be plus sigma 1 2 pi a1, so it's like a 2 times this. This is 4 pi sigma 1 a1. So that's the surface tension force, and the force from pressure difference will be the normal component will be left, and normal component will be as if it's act on that area. It's acting on this this area, right? It's acting on that area, but because horizontal cancelling out, it's as if the force is acting on this area. So delta P1 times pi r square, and this is equilibrium. That means this force and this force must be equal to each other. So delta P1 pi a1 square equals to 4 pi sigma 1 a1. So delta P1 will be 4 pi sigma 1 a1 over pi a1 square. So pi cancels out this, so this is 4 sigma 1 over a1. So we kind of need to know this. So a1 can be had if I can figure out the volume change, okay, which we can figure out, right? So like what the volume area is times pressure, what the volume area is times the pressure, that give me the volume. So I can figure out a1 for sigma 1. We will make assumption that sigma 1 here and sigma 0 surface tension over here is going to work out the same way. It's going to be sigma 0 times 4 sigma 0 over this radius a should equal to delta P0, right? The same formula as this one. We work out on this bubble. It's going to be like this. But there are too many unknowns here. We don't know sigma 0. We don't. we don't know A0. And so one way to handle that is reduce the number of variables, and we make one reasonable assumption is that surface tension sigma 1 here, let's see, surface tension sigma 1 here is, and surface tension in this area, this particular case, they are the same. Or we say sigma 0 is sigma 1, just use or call this sigma. So let's look at this. So delta P1, we want delta P1. So delta P1 will be, if you take a ratio of this delta P1 over delta P0, then I have a 1 over A1 4 sigma A0. And so this is A0 over A1. So all I have to do is figure out this ratio. And I can figure that out by using Gauss law. Okay, so this becomes just search for this, right? Now we use Gauss law, P0 V0 for this volume, and we're gonna I know it's P0 plus delta P0 V0 equals to P1 plus delta P1, the pressure inside and pressure inside, delta P1 times V1. But they tell you to ignore this compared to that. So this approximately P0 V0 is P1 V1. I only need the ratio of this. So V0 over V1 is P0 over V0 P1 over P0, and P1 over P0 is given. So P1 is 8 over 27. The volume I can also write is 4/3 pi A0 cube and 4/3 pi A1 cube. So 4/3 cancels out, and so this is A0 bar A1 cube, and so but this one is 2 over 3 cube. So this tells me A0 over A1 is 2/3. So that tells me A1 is 3/2 A0. So this turns out to be A0 over A1 is 2/3. It's 2/3. So delta P1 will be, I put over there, times delta P0 for delta P1. So delta P1 will be this, and 2/3 times 144. Pause this, see if I made a. So so I got 96 Pascal. I hope I didn't make some mistakes here, but okay, this looks like correct, 96. So the answer is 96. Okay, well, it was a pretty interesting problem. You get to actually learn about like two sides of a bubble, and so that's why you need 4 sigma 1 over a1. If you just had one film, if you had one just very thin film, and you want to know what just one surface, then the pressure difference would have been just 2 sigma over the radius r. But here you have two surfaces. That's why you need 4 sigma. That's one of the places that you could have kind of tripped up. But other than that, I think I should write down here over here delta p over delta p for this is 2 sigma over r. Other than that, I think the rest is pretty straightforward. Okay. All right. I'll see you in another video. Bye.